This is the first lecture of non-parametric test. Today I discuss sign test. Many statistical tests requires that your data follow a normal distribution. Sometimes this is not the case. In some instances, it is possible to transfer or transform the data to make them follow a normal distribution. In other words, or in others, this is not possible, or the sample size might be so small that it is difficult whether or not the data is normally distributed. In such cases, it is necessary to use a statistical test that does not require the data to follow a particular distribution such a test is called a non-parametric or distribution free test. So many statistical tests require that your data follow a normal distribution. Sometimes this is not the case. In some instances, it is possible to transform the data to make them follow a normal distribution. In others, this is not possible, or the sample size might be so small that it is difficult whether or not the data are normally distributed. In such cases, it is necessary to use a statistical test that does not require the data to follow a particular distribution. Such test is called a non-parametric or distribution free test. First, I consider one sample problems. Here we shall discuss non-parametric version of student's t-test for one sample and pair sample cases. The t-test is based on the assumption of normality based on, if you consider single sample, since I consider one sample test, so this test based on the normality of a single population, or if we consider pair sample case, in that situation, or of the population of differences in the case of a bivariate population. The non-parametric test will be based on some continuity assumption about the population. And non-parametric problems, the median is taken as location parameter rather than the mean. Sign test. Let x1, x2, xn be a random sample from a population capital F suffix capital X with unknown median theta, say where fx is assumed to be continuous in the neighborhood of theta. Now we want to test H naught, that is null hypothesis, theta equal to theta naught. This is a given value or hypothesized value against one-sided or two-sided alternatives. Under continuity assumption, probability x less than theta equal to probability x greater than theta equal to half. If the sample comes from the population with median theta naught, then we observe that on the average half of the sample observation will lie above theta naught and half below theta naught. So if we form the n differences xi minus theta naught I from 1 to small n and find out the number of positive values, say we denote this by small r, and number of negative values, say small s, in these differences then the number r may be used to test H naught. It is obvious that R plus S should be less than equal to small n, where small n is a number of observations. Since if H naught is true, then if H naught is true, then probability x less than theta naught, if H naught is true, then probability x less than theta naught half equal to probability x greater than theta naught. So if your alternative, that is a right tail test, if this alternative HA greater than theta naught, this is simply P greater than half, where P is a probability that x less than x greater than theta naught. And under H naught R follow binomial distribution with number of trials is a R plus S and success probability is half. Since if R is large, this implies theta should be greater than theta naught. So the critical region for testing H naught theta equal to theta naught versus HA theta greater than theta naught is this R should be greater than R alpha, where alpha is a level of significance. Where and R alpha is obtained from, or R alpha is such that probability R greater than R alpha under H naught is less than equal to R, less than equal to alpha. This is because of the discreteness of binomial distribution. The test may not be of exact size alpha. So this is equal to r plus sc x, where x running from r alpha to r plus s half to the power r plus s less than equal to alpha. So solving this, and we get the value r alpha. You can find this r alpha from binomial table, or you can use statistical software. For example, if you use R, then you use the code q binom alpha r plus s (0.5), and you get this value r alpha. Sorry, this is not correct. So for r you should use in that way, because q binom is a CDF, cumulative distribution, or less than type probability. So first of all you need to make it in that way. So this is equivalently, we write it 1 minus probability r less than equal to r alpha minus 1 under h naught. This is less than equal to alpha, or this is probability r alpha minus 1 given h naught greater than equal to 1 minus alpha. Then you use r code, that is q binom (1 minus alpha r plus s 0.5). This gives r alpha minus 1, and then you find r alpha is a q binom 1 minus alpha r plus s 0.5 plus 1. Actually q binom is a, here I write this, what is q binom, what is the meaning of q binom. Q binom, this evaluate, suppose your x follows binomial n comma p, then fx naught equal to probability capital X less than equal to small x naught. You want to find x naught. So for this you use this code q binom suppose this probability is say P star, then P star n comma P. So this code, R code, gives the value x naught. So you can use R code for finding R alpha, or binomial tables, or you can use Excel or any other statistical package for finding R alpha. Now note that the theoretically no zero differences xi minus theta naught exist, because of continuity of the population in the neighborhood of theta naught. But in practice there may arise zero differences. The usual method is to ignore those n minus r plus s zero differences and to take r plus s as the sample size. Now if you interested for left tail test, that is, if your alternative HA mu, your alternative HA theta less than theta naught, then we expect, and this is equivalently P less than half, so we expect that your critical region should be, that is, your R should be as small as possible. If your R is small, then this is favor, or this is suggests that you accept or you reject H naught or accepting HA. So the critical region should be R less than R alpha star. So when you interested in left tail test, that is your true median less than theta naught, that implies your maximum or maximum value means half of the more than half of the observation lies below theta naught. So this suggests your number of positive values, that is xi minus theta naught, should be small. So your critical region should be R less than R alpha star, less than equal to R alpha star, where alpha is a level of significance. And similarly we can find R alpha star as, this is R less than equal to R alpha star under H naught equal to alpha. Similarly you can use for finding R alpha star, that is cutoff point for, you can use binomial table or Excel or any other statistical package, and if you use R then you can use this code Q binom alpha R plus S 0.5. So this gives R alpha star. Similarly, if you are interested for two-tailed test, that is a non-directional test, then your alternative hypothesis should be theta not equal to theta naught. This implies P not equal to half. In that case, your critical region either your R greater than R alpha by 2 or your R less than equal to R alpha by 2 star. Similarly you can use, so for R alpha by 2, given H naught, this is equal to alpha by 2, this is less than equal to alpha by 2, and already I mentioned that discreteness of binomial distribution, we cannot find exact alpha by 2. So instead of equal to alpha by 2, we write less than equal to alpha by 2, and R less than equal to alpha by 2 star given H naught less than equal to alpha by 2. So similarly you can use binomial tables or any other statistical software. You can find R alpha by 2 and R star alpha by 2 for two-tailed test. Now if your n is large, say your n is greater than equal to 25, in that case we can use large sample test. That is, we know R asymptotically normal with expectation of R under H naught R by 2, and variance of R is, that is R plus S by 2, expectation R equal to R plus S by 2, and variance of R equal to under H naught, that is NPQ, that here N is R plus S, P and Q both are half, so under H naught, that is r plus s by 4. So here I mention one thing, that is n should be greater than equal to 25 is not correct, because we consider instead of n r plus s, so it is better to write r plus s should be greater than 25. Some author consider exact 25, or some author consider greater than 25, r plus s should be greater than 25. It is better to write r plus s greater than 25. So under this condition, r asymptotically normal with mean r plus s and variance r plus s by 4 under h naught. Then our Z statistics, r minus r plus s by 2 root over r plus s by 4, which is equivalently r minus s divided by root over r plus s. So if your r plus s greater than 25, then you use this test instead of exact test. So I give some homework to you. So please submit this homework. Problem 1. Find the power function of the sign test with respect to the alternative p greater than half, and draw the power curve. Problem 2. Find the power of the sign test for h naught theta equal to 45 against theta greater than 45 for r plus s equal to 18 under the assumption that the population is normal with mean mu equal to 50 and sigma standard deviation equal to 5 and level of significance alpha equal to 0.05. Suppose we interested state of median population quantile, that is pth quantile. So your job is to construct test based on sign test for testing h naught xi p equal to xi naught is the pth quantile. Versus xi p greater than xi naught, and also compute its power function. Now I consider a practical example to illustrate the procedure. Suppose that we want to test the hypothesis that the median length theta, this is a median length. So first I write the problem. Suppose we want to test the hypothesis that the median length theta of ear head of a variety of wheat is theta naught equal to 9.9 centimeter against the alternative that theta not equal to 9.9 centimeter with alpha equal to 0.05, that is level of significance. On the basis of following 20 ear head measurement, nine point three, 8.8, 10.7, 11.5, 8.2, 9.7, this is 11.5, 9.7, 10.3, 8.6, 11.3, 10.7, 11.2, 9.0, 9.8, 9.3, 9.9, 10.3, 10.0, 10.1, 9.6, 10.4. So here we observe that R equal to 10, that is number of xi minus 9.9, or rather it is number of xi which greater than 9.9. I already mentioned this is denoted by R, and this R should be 10. And since your alpha is 0.05, so here I consider both tail test. So our alpha by 2 you find this value is 15 and R star alpha by 2, so this value is 4. Here S is 9 because one observation, that is 9.9 equal to this 9.9, so I exclude this. So therefore S should be 9, your R should be 10, and these are alpha by 2. So first I mentioned this thing. So your rejection region R should be greater than equal to R alpha by 2 or R less than equal to R alpha by 2 star. So using R code, you find that your R alpha by 2 is 15 and R star alpha by 2 is 4. Then since your observed R is lies between 4 to 15, so we fail to reject H naught at 5% level of significance and conclude that there is sufficient evidence that the length of ear head variety of wheat is 9.9 centimeter. Similarly, you can test if your alternative is 9.9, theta greater than 9.9 for right tail test, and if your alternative is less than 9.9, that is for left tail test, you can find R alpha in this case, and in this case you can find R alpha star, and using same procedure you can make a comment on your hypothesis. So this is your homework. So in my next class I will discuss another method, that is Wilcoxon sign rank test, and at the end of this class I will illustrate the Wilcoxon sign rank test through an example. So till then, please stay with us. Thank you.